Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Galih. I come I come group 5. In this video, I will continue my previous video about the measurement and estimation. In the previous video, I will explain the vocabulary video and chapter 2 explain 7, 8, 9, and 10. Okay, let's just explain the vocabulary first. Algebra. In Bahasa is algebra. Algebra is the part of mathematics that help represent problem or situation in the form of mathematical expression. In algebra, we use numbers like 2, -7, or 0.068, which have a definite or fixed value. In algebra, we use a variable like x, y, and z along with the numbers. Such use in algebra. Example: William had a few chocolate with him. They come across and he took away 5 of his chocolate, and then we had just 7 chocolates remaining with him. Now, how many chocolates did he have before they come to him? And so we let the chocolate be x. So we can write it as x minus 5 is equals to 7. And now addition from both sides with 5, so we have x minus 5 plus 5 is equal to 7 plus x, and x is 12. Second, coefficient. In Bahasa is coefficient. Coefficient, an integer that is running along with the variable or it is multiplied by the variable. In other words, a coefficient is the numerical factor of term containing constant and variable. Example: the term 2x, 2 is the coefficient. Function. In Bahasa is fungsi. Function is a mathematical and expression rule or law that defines a relationship between one variable or the independent variable and another variable or the dependent variable. A function assigns exactly one output to its input of a special type. It is often written as fx, where is x the input value. Example: 5x is equal to x per 2. It is a function because its input x has single output x per 2. So f2 is equals 1. f16 is equals to 8. Greater than. Symbol is that in Bahasa is lebih besar dari. The greater than is a match is placed between two values in which the first number is greater than the first number is greater than the second number. Example: 10 is greater than 8. 5 greater than or equal to. In Bahasa is lebih dari atau sama dengan. Greater than or equal to is used to represent any inequality in math. It tells us that a given variable is either greater than or equal to particular value. Example: student greater than or equal to 50. Less than. The less than sign is one the inequality sign, which is used to compare the number. If the first number is less than the second number, less sign is used. For example, 5 is less than 10. It means the number 5 is less than the number 10. Term. In Bahasa is suku. A term can be a number, variable, product of two or more variables, or product of a number and variable. An algebraic expression is formed by a single term of a group of terms. Example: the expression 5x plus y, the two terms are the expression is 4x plus y, the two terms of 4x and y. Factorization. In Bahasa is factorisasi. In math, factorization is when you break a number down to smaller number, then multiply together give you that original number. When you split a number into the factor or divisor, that's a factorization. Example: factorization of the number 2 might look like 3 times 4. Digit in bahasa is angka. Digits are the single number used to represent value in a math, like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Are used a different combination and the representation to represent all the value in the math. Only of 10 numbers from 10 from sorry from 0 to 9 can be represented by a symbol known as a digit. An example of a two-digit 2D number is 65. Number in bahasa is bilangan. A number is arithmetic value used to represent a quantity. Hence, a number is a mathematical concept used to count, measure, and label these numbers from the basis of mathematics. For example, this is a one butterfly and these are four butterflies. Next, I will explain the question from the video. The problem is to find a value of x from the following equation. We have the equation 3x plus 5 equals 7 and 2x minus 2 is equals to minus 10. First, 3x plus 5 is equals 7. Now, we subtract 5 from both sides. So we have 3x plus 5 minus 5 is equal to 70 minus 5. 7 minus 5. 70 minus 5. 3x is equal to 12. And to isolate x, multiply both sides by 1 per 3. So we have x is equals to 4. Second equation, 7x minus 2 is equals to minus 10. Now, we addition to from both sides, so we have 7x is equal to minus 8. And to isolate x, multiply both sides by 1 per 7, so we have x is minus 80 per 7. X minus is equals minus 8 per 7. And finally, I will explain chapter 2, example 7, 8, 9, and 10. Example 7. The question is, Alison and Rahel were competing in race. Alison had 10 minutes head start and was running at 3 km per hour. Rahel ran at 5 km per hour. And how many minutes did Rahel catch up with Alison? Solution is, model of the problem is distance traveled by Alison is equal to distance traveled by Rahel. Since we are asked to find Rahel time, we will represent it by t. Note that the unit of the t must be hour, since the rate of a given in hour. Alison ran 10 minutes more, which will represent by t times 1 per 6, since 10 minutes is 1/60 of an hour. Let t is Rahel time, so t times 1 per 6 is Alison time. Using the distance is equals to rate times time, we have 3 quantity t plus 1 per 6 plus quantity is equals to 5t. We multiply, so we have 3t times in half 1 per 2 is equals to 5t. And we have now we subtract both sides of the equation with 3t, so we have 1 per 2 is equals to what? 2t. So t is 1 per 2 divided by 2 is 1 per 4 hour, or t is 5 minutes. To check, we compute the distance traveled by each girl using t1 is equal 1 per 4 for Rahel, and the t is 1 per 4 times 1 per 6 so 5 per 12 for Alison. Rahel's distance was 5 times 1 per 4 is a 1.25 kilometer, and Ellison traveled 3 times 1 per 12 is 1 per 25 kilometer as well. Note that we could have converted to the rates of kilometer per minute by dividing each other by 60. It would allow the present minute, and we could use 10 minutes in the question instead of 1 per 6 hour. So a quantity 3 times 3 per 60 equals quantity times a quantity t plus 10 plus quantity x is equals to 5 per 60 t, and times, so we have 3t per 60 plus 30 per 60 is equals to 5t per 60, and we multiply by 60 from both sides, so we have 3t plus 30 is equals to 5t, so we have subtraction from both sides by 3t, so we have 30 is equals to t, so to solid t we multiply by 1 per 2, so we have t 50 is equals to 50. The relationship used in this problem can be written to expression the rate of equation is rate per distance traveled per time. Example 8. The question is, if you can paint 5 rooms and 8 hours, and Samantha can paint 3 rooms and 6 hours, how long will it take them to paint 7 rooms working together? Solution 8. Using the rate formula, we see the choose rate of work is 5 per 8 room per hour, and Samantha rate of work is 1 per 3 room per hour. Let T is the time to complete the job together. The model is total number of room painted is equals to room painted by Joe and room painted by Samantha. So we have 7 is equals to 5 per 80, and 80 plus 1 per 2t, and so 7 is equal to 5 plus 4 per 80, and 7 is equal to 9 per 80, and so we times both sides with 8, so we have 56 is equals to 60, so and we times again from both sides with by 1/9, so we have time, so we have t is equals to 56 per 9, and t is 60 and a half t. Explain 7. The equation is, it takes Suzanne 10 hours longer than Laurie to take their store inventory if it takes 3 times the 3 pairs. 4. For them to do the job together, how long would it take Suzanne to do it alone? The solution is, since Laurie takes less time to complete the job, we'll let her take it divided by t. If we can find the times time, the answer to the problem will be plus 10. The number of jobs considered of this problem is 1. Therefore, Laurie's rate is 1 per t. The Suzanne's rate is 1 per quantity t plus 10. The model of the problem is 1 job is equal to amount done by Suzanne and amount done by Laurie. Using 50 per 4 for 3 per 4, the amount done by Suzanne is 1 per t plus 10 is times 50 per 4, and the amount done by Laurie is 1 per t is times 1 is times 50 per 4. Substitute into the preceding model, so we have 1 is equals 1 per t, 10 times 50 per 4 plus 1 per t times 15 per 4 is equals to 15 per 4 is times per quantity 1 per t plus 10 plus 1 per t. So we have 1 per 50 per 4 and 1 per t plus 10 plus 1t. Simplify the fraction on the left to get the fractional equation. 50 per 4 per 50 is equals to 1 per t plus 7 plus 1t, and we multiply by both sides with t plus 10, so we have 4t times the quantity t plus 10 plus quantity is equals to 50 plus 50 times quantity t plus 10. So we have 40 squared plus 50 is equals to 30 plus 150. So we have, and the fraction both sides by a 3t and 150. So we have 4t squared plus 10t minus 150 is equals to 0. And we multiply by 1 per 2 from both sides. So we have 2t squared plus 50 minus 75 is equals to 0. So quantity 2t plus 50 times plus quantity times quantity t minus 5 plus quantity is equals to 0. So we have t is minus 7 or t is 5. Since the problem requires physical time, we reject the negative answer and we see that 10 that is equals to 5 is allowed times. Therefore, Susan can complete the job in the 15 hours working alone. Example 10. At the chocolate factory, John's job to experiment with mixing different amounts of milk and chocolate to find different flavor. If he mixed 2 quarts of the type A which contain 50% chocolate with 1 quart type which contain 10% chocolate, he create type C. What percent of the type C is chocolate? The solution is, in this solution, we write the percentage of chocolate for each type. We have the relationship amount of chocolate in the type in percent of chocolate times amount of the type. Amount of the chocolate in the type B is 1.3 quart of chocolate. The amount of chocolate in type B is 1.1 quart of chocolate. To find the total amount of chocolate in the mixture, we add the chocolate quantity from type A and type B. The total amount is 0.4 quart. Next, we need to determine the total volume of the mixture, which we obtain by adding the value of type A and B. So total value of the mixture is 3 quarts. To find the percentage of chocolate in type C, we divided the total amount of chocolate by the total amount of the mixture and multiply by 100. So we have 1.4 quart per 0.4 quart per 0.2 quart is times 100 is 30 33 minus 30%. Therefore, type C contains approximately 30.33% chocolate. So, thanks for watching. See you again in my next video. Assalamualaikum warahmatullahi wabarakatuh.